Okay, so medium X could be air, and medium Y could be water. They don't specify in the question. And then we have some kind of a wave that's traveling down along here and then into medium Y. And it could be a sound wave. And so it does pick up speed as it goes into medium Y, and sound waves do go faster in water than air. So then I've got my given information up here for X. I've got my velocity in medium X is 800 meters per second. They tell me that. They also tell me the wavelength in medium X is 4 meters. And then in part A, they ask for the frequency in medium Y, which is odd. But it's easy if you have that conceptual information that once the frequency is created at the source, the frequency remains the same. You might speed up or slow down as you move into new stuff, into a different medium, but the frequency is the same. So the frequency in Y will be equal to the frequency in X. And that then is findable with the information we have. So we're going to start with our wave equation, V equals lambda times F. Maybe they'll put in the X's here for medium X. So the velocity in X equals lambda X times the frequency in X. And then let's go ahead and put in the numbers. We're going to substitute. So we'll have 800 meters per second equals 4 meters for lambda. I'm going to put that in parentheses, and we can solve for fx. So we're going to divide both sides by 4 meters. 4 meters. The 4 and the 4 and the meters cancel out. 800 divided by 4, what's that? 200. And then the meters per second over meters, the meters get to cancel. Bam, bam. But then you have 1 over seconds equals your frequency x. So what is 1 over seconds, really? What do we call that? Yeah, so 200 hertz. Remember that 1 is like 1 wave per 1 second. So this is 200 waves per second. And then that also equals the frequency in Y, because frequency isn't going to change as you change into a new medium. So there's our answer for part A. All right, now let's cross over into part B. They're asking for the wavelength now in medium Y, and that's going to be in meters. And so you can see from my picture, the wave speeds up, and when the wave speeds up, it stretches out, and so your wavelength gets larger. And they gave us a new speed. They said the speed in Y is equal to 1600 meters per second. So then we're just going to use our equation one more time. Vy, lambda y, Fy. And let's put in our 1600 meters per second for Vy. And lambda y is what we're looking for, so we'll leave that as lambda y. Our frequency doesn't change, so we're going to put in our 200 hertz. And then what do? Yeah, thanks, Alex. We're going to divide both sides by 200. And now we get to slash, 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 slash. And we have 1600 divided by 200. What's that? A nice clean 8 meters per second over hertz. Little sidebar on that. So meters per second divided by hertz. And a hertz is the same thing as 1 wave per second. So that's the same thing as calling it meters per second times 1 over hertz. And since a hertz is the same thing as an inverse second, then that's the same thing as a second over 1 when you have inverse hertz. So now you can see, we get to cancel our seconds with each other, and we're just going to get meters over 1, which is the same thing as meters. And that's good because that's the unit for wavelength. So your units always work out if you set up your equation correctly. All right, cool.